Alright, we're taking a look at our next section here. We're looking at multiplying and dividing rational expressions. So we know rational expressions, so a ratio of two polynomials. So numerator polynomial and denominators of polynomial. So first thing we need to do is factor everything that can be factored. So greatest common factors, every type of factoring that we've dealt with, we need to make sure that it's done. All right. Simplify the monomials using exponent rules, so something we've taken a look at, and then eliminate common factors. That's what we're going to do. So the denominator can never equal 0, so that would make an expression undefined. We know we cannot divide by 0. So on example 1, simplifying the expression, then determine what conditions this expression is undefined. So let's go ahead, we need to factor out first. So factor this top one, so we have 5x, times, if we factor out that quadratic, we have x plus 3, x plus 1, all over x minus 6, that can't be factored. And then x squared minus 9, we remember that we can factor out to be x plus 3, x minus 3. All right, so we've factored everything out. Now we can start canceling what we can cancel. So x plus 3 is on the top and the bottom. So we can go ahead and cancel that out. So everything else that's left, we need to put back together. So 5x times x plus 1, we get 5x squared plus 5x all over, multiply these two back together, we get x squared minus 9x plus 18. So that is our final answer. And now we need to determine what would make the expression undefined. So we're looking back here at this step. We're looking at what would make the bottom be 0. So we look at each factor that's on the bottom and we find what would make that 0. So we have a situation to where x cannot equal 3 and x cannot equal 6. Okay, so we put a little comma there. We have our expression, comma, and then what would make it undefined? What would make the bottom be 0? All right. Let's skip over those checkpoints. We can talk about those in class during our meeting. All right. So sometimes you can factor out a -1 in the numerator or denominator to help simplify an expression. So what I mean by that, we'll see here in the second step, I believe. So let's take greatest common factor out of this first one. So greatest common factor out of there is a w. Okay, so w comes out. So 4w minus 3y times w plus y all over no greatest common factor, no greatest common factor. We can't factor these, so we're going to go ahead and write those as we see them. Okay. So actually we can do the second step right now and combine steps. If we can recognize this and this, so what's on the top here and the bottom here are similar. The problem is, so the order is wrong and then the signs are going to be wrong. So if I were to rewrite this, I could say that 4w plus 3y. That's the same thing, right? We know order of addition does not matter. So the negative 4w plus 3y. So notice how the signs are opposite. So what we can do is factor out a negative 1 out of this and rewrite it as 4w minus 3y to get it to match. Okay, so take some time to think about that. So pause if you have to, but that's a huge thing that we can do. Saves time later on. So we know that this and this are the same, and nothing else can cancel out. So we're going to go ahead and multiply back. So we have w squared plus wy all over. Now this negative on the bottom, if the negative's in the bottom or the top, we could write it out front, okay? You can write it out and make it a negative fraction. You could distribute it into the top or the bottom, and it stays equivalent, that's fine. And if we had a negative on the top and the bottom, we know those just cancel. So what we're left with here is this 5w plus y. Again, like I said, you could have the top over a negative 5w minus y. You could also have negative w squared minus wy over 5w plus y, or just have the negative out front. I like to keep it out front. I think a little nice. All right, so now we are to multiplying. So multiplying steps, factor, everything can be factored. So same thing that we just did. Divide out the common factors. So that's what we did with the canceling, something on the top and the bottom that matches. And then we can put the numerators and denominators together. And we know if we multiply two fractions together, and we just multiply the top to the top and the bottom to the bottom. Okay? And then we can go ahead and simplify again. So we're just starting with a simple expression here. So let's go ahead and cancel what we can cancel. So we know that we have an x to the fourth. So this is something we dealt with the other day. So 2/3 does not reduce. So we write 2/3. X to the fourth over x squared we know is x squared on top, and then y to the fifth. Okay, times 15 over 8, that does not reduce, so we just leave it like that. X squared over x cubed, we know that turns into an x on the bottom, and then the y squared just stays on the bottom. Sorry, that's an x. So when we put these together, we get 2 times 15, which is 30. And then we get x squared over, x squared y to the fifth. And then 3 times 8 is 24. X y squared. And now we can simplify again. So 30 over 24. Okay, so 6 goes into both those. So 5 and 4. X squared over x, that turns into an x on the top. Y to the fifth over y squared turns into y to the third on top. And that would be our final answer here. Okay. Now some of us are good enough to cancel in this step here. Okay. Well, sorry, from our original to this part here, we could cancel all the x's that show up. You know, you guys can think about that as being x to the sixth and x to the fifth, and so on and so forth, and dividing out common things with all of these. So you guys, some of you are going to be able to figure it out. out right now. Some of you, it's going to take some time to grow. So just take your time, go slow. That's where most mistakes happen, is when people think these are just super easy and they just go real fast. All right, so this one, what we're going to do is we're going to kind of do it a little bit differently, because we're talking about binomials here. We're talking about functions instead of just simple expressions. What I want to look at, I'm going to multiply these two together first, but I'm not going to actually multiply them. I'm just going to put them next to each other. Okay, so we're combining the two fractions right now. So numerator times numerator, denominator times denominator. But when I do the bottom, I notice I can factor some stuff out. So this first one has a greatest common factor of 3, so we can take that out. So x plus 4. And then this one would factor out to be x plus 2, x minus 2. Alright, so the hardest thing for some people is seeing greatest common factors right away, but I think we've had enough practice at doing that first before we do everything. I think that's going to help a lot. So x plus 4 is canceled. This x plus 2 cancels. And we're left with what on the top? We're left with a 1, remember? So everything's multiplied by 1. It just doesn't show up. So 1 over 3 times x minus 2. So we can go ahead and multiply that. So 3x minus 6. All right. Let me see. I gotta go back here real quick. No, we're good. All right. So the next one, factor. So factoring the first one here. So we know that this would factor down. We can take this in a couple steps here. We see a greatest common factor right now of 4. So I'm going to do that up here. So 4 out, that makes that 2x squared minus x minus 10. It's just going to save us some steps and some writing. We don't need to write all this a bunch of times. So now what we're looking at factoring just this. So that would be 2x times x, because that's the first term. And we need to think about, so factors of 10 that we could use. So we have 2 and 5. So 2 times 2 is 4, and 5 times 1 is 5. And we know if we make the 5 a negative and the 4 a positive, that would end up being -1. So again, if you need help factoring any of these, that's a separate conversation that we have to have, just because the amount of time that we've already spent on factoring. So factor this out. We end up with x minus 2, x minus 5. So that's all the top factored out. I put them together in one numerator. And then factor these out. We're going to put them together on the bottom. So this x squared term here goes factored out to be plus 7 minus 5. It's a 7. And then this one, we have a greatest common factor of 4. So let's pull that out first. And that becomes x squared minus 4, which factors down to be x minus 2, x plus 2. Okay, so if you need a little side note there, if we factored out a 4, that would be x squared minus 4. And that's what we're breaking down to get this. Okay, so take your time with the factoring, make sure everything goes in the right location, and then we can start canceling. So I see that we have a 4 on the top and a 4 on the bottom. That cancels. We have an x plus 2 and x plus 2. X minus 2 cancel. X minus 5's cancel. And all we're left with is this 2x minus 5 over x plus 7. Okay, so final answer there. So kind of cool that this whole big mess breaks down to this simple expression. And if we were to find what would make these 0, what would be undefined, 0 in the denominator, we just set factors equal to 0 and solve. So this one would end up being a positive 2 for the x, so x could not equal 2. This one, x could not equal negative 7 if we were asked. We're not asked, it just says simplify each expression. Okay, but just a little practice for you. All right, then the last thing that we need to talk about in the video is how to divide rational expressions. So we remember that, I'm going to take a little side trip here. So we know, actually let me come up with a better, 2/3 divided by, let's say 5/4. 2/3 divided by 5/4. We know that that is equivalent to 2/3 times the reciprocal of the bottom, 4/5. Okay, that would end up being 8 over 15. All right, so dividing two fractions, we just flip the bottom fraction and multiply the fractions together. So that's what we are doing when we're dividing two fractions. So two rational expressions are just two fractions. So we need to flip this to multiplication, and we're flipping the second fraction. Whatever fraction we're dividing by is what we're flipping, okay? So I'm going to write that out for the first problem, and then we're just going to think about it in all the other ones. So that becomes first fraction stays, stays normal, times the reciprocal of the second fraction. So we are flipping that second one, okay? And now we can just do what we've been doing in all the other examples. So we can go ahead and cancel some stuff. We can multiply. So first thing that really jumps out to me is we know that these are going to be together at the end, right? Numerator times numerator. So all these things are in the numerator for the new fraction. All of these are in the bottom for that fraction. So the 9s, we can just go ahead and cancel out right now. Okay? And then the 4 over 16, 4 divided by 16, we know that reduces to 1 over 4. So 1 is up here and a 4. Okay. Actually, I'm just going to leave the 1 out. We know it's there. We have to put it up there if nothing else is in the top, but let's see. X cubed divided by x squared. There's no other x's here. So that's all we have. So we have an x on top. Y to the 5th and the y. So that's all the y's. Y to the 5th over y becomes y to the 4th. Okay, so final answer is right here. So you can take care of a couple steps in one step if we just slow down and think it through. All right. Now these are a little harder to do that. We actually have to write these out. So we know that this second fraction is flipped. So we know that this is on the top, and we know that this is going to be on the top. So when we're factoring, that's what we're factoring first, and we're just going to put it on top. So x squared minus 4 goes to x minus 2, x plus 2, this factors out to be x minus 1, x plus 1. So there's the top, and now we can factor the bottoms. So we know that the bottom is going to be this one and this one. So factor out this one here. We have x minus 2, x plus 1. And then this one would factor down to be x plus 2, x plus 5. Okay, so now we can cancel what we can cancel. X minus 2's go away, x plus 2's go away, and x plus 1's go away. So we are left with an x minus 1 on top and an x plus 5 on the bottom. Okay, if we were asked to say what would make this undefined, x cannot equal negative 5, because that would make the bottom be 0. All right, let's talk about one more problem here, and then we'll be done. So this is a little goofy, because we're just dividing by a polynomial here, not a rational. But we can think about what that really is. We know that that is over 1. So when we change this to multiplication, this flips, and the 1 is now on top. So factoring out this, and this would go on top. Okay, so the fact that 1 goes on top, that's nice. So we just had to focus on factoring that. So we have x, we have a minus 3 plus 2 times 1. We don't need to show that, so we can just go ahead and put this on the bottom. So this goes on the bottom, x plus 1, times the factor of this, which is x plus 2, x plus 5. And cancel what we can cancel. Well, x plus 2 goes away, and nothing else cancels. So we're left with x minus 3, and then we're going to put these back together. So x squared plus 6x plus 5. And again, if we wanted answers that would make this undefined, we would say x cannot equal negative 1 and x cannot equal negative 5. All right. So one last thing I want to talk about. I'm going to go back to the front. So go ahead and, oh, maybe it's not, it's this one. So when we're talking about x's that would make it undefined, we need to take into account anything that's canceled out too. And we're going to learn this in a couple days, why we need to account for this. So I'm going to add in x cannot equal negative 3. So negative 3 would cause this to be 0. So we're going to go ahead and put that back. Okay. So that's a huge thing there. So we have to do all that's canceled, all the things that are canceled, and really you can think about just writing them before we do any canceling. All the factors that are in the bottom, you can write those out, and then you won't have to worry about it. But again, we'll talk about that. Why is this one of them? All right. So that's the end. So let's ask any questions that you might have, and we'll go from there.